So building on this relationship between the dot product and the lengths of vectors, we know that the angle between any two vectors can be given by this formula here. So if we have the vectors a and b, we can say that the dot product of a and b is going to be equal to the product of their lengths, so the length of a times the length of b, multiplied by cosine of theta, which is the angle between them. So theta is the angle between the two vectors, which means that if we can just find the length of each vector and the dot product of the vectors, we can solve for cosine of the angle, and then we can find the angle itself. Now we get some interesting things from this formula. For instance, let's look at vectors that we know are perpendicular. So if vectors are perpendicular to each other, then the angle between them, of course, is 90 degrees. That's just a right angle. If we have a right angle like this, let's say our vectors look like this. We have one vector here and one vector here. If they're perpendicular, that means this is a right angle, and a right angle is always a 90-degree angle. So if we know the vectors are perpendicular, we can plug 90 degrees in for the angle theta. When we do that here, we get cosine of 90 degrees, and cosine of 90 degrees is always equal to 0. That value is always 0, which means that we're going to end up zeroing out the entire right-hand side. So when we have perpendicular vectors, what we're left with is the dot product of a and b equal to 0. What that tells us is that if we ever take the dot product of two vectors and the result that we get is 0, that tells us right away that the vectors are perpendicular, or if we're in three-dimensional or n-dimensional space, that they are orthogonal to each other. So finding a dot product of 0 means that the vectors are going to be perpendicular or orthogonal. So for instance, let's do an example where the vectors turn out to be orthogonal. Let's say that we have the vector a, and that's equal to, let's even do this in 4 dimensions. Let's say we have 1, 0, -2, 0. And then we have the vector b, and in 4 dimensions that's 0, 3, 0, and 1. Then we can see right away if we take their dot product, so the dot product of a and b looks like this, we're going to get 1 times 0 when we multiply the first two components together, plus 0 times 3, the product of the second components, plus -2 times 0, which is the third components, plus 0 times 1. And of course we'll get 0 plus 0 plus 0 plus 0, and the result there is 0. So because we found that the dot product was 0, that tells us that these two vectors here are orthogonal to one another in R4. They both exist in R4 space. They are orthogonal to each other in R4. So the idea, of course, is that that works for any dimension, no matter what space I'm in, R2, R3, R4, Rn. If I get 0 for the dot product of two vectors, I know that they are orthogonal. Let's look now at finding the angle between two vectors using this formula. We can see here that if we actually used these two vectors in R4, we get a dot product of 0. We would get 0 on the left-hand side here. And then regardless of the lengths of a and b, so let's say we have the length of the vector a, the length of the vector b, and then cosine of the angle between the vectors, we could divide both sides by the product of the lengths of a and b. We would get 0 divided by the length of the vector a times the length of the vector b, and that would be equal to cosine of the angle between them. Well, 0 divided by any non-zero value, and we know that these here are non-zero. The length of a and b are both non-zero. So here on the left-hand side, we'll just get 0 is equal to cosine of theta. And then we can say that we know that cosine of an angle is equal to 0 only when that angle is 90 degrees. So we get that 90 degrees for theta, which tells us that these two vectors are orthogonal, which we already knew because we found that the dot product was 0. But that's how we see it come out in this angle between vectors formula. Let's take another example though. Let's say we have the vector a, and that's equal to 0, 3. And then we have the vector b, which is equal to -1, -4. If we want to find the angle between the vectors, we'll simply take their dot product first. So the dot product of A and B will be equal to 0 times -1 plus 3 times -4, or 0 minus 12, or -12. So that's the dot product. Now we need the length of A and the length of B. So the length of vector A will be equal to the square root of 0 squared plus 3 squared. That's going to be the square root of 9, which is 3. And then the length of B, we know, is the square root of -1 squared plus -4 squared. That's going to give us the square root of 1 plus 16, or square root 17. So if we plug all these into our formula for the angle between vectors, we get on the left-hand side the dot product of -12 is equal to 3 times root 17, the product of the two lengths, so 3 root 17, and then cosine of theta. So to find cosine of theta, we just divide both sides by 3 root 17, so we get -12 over 3 root 17. If we divide both the numerator and the denominator by 3 to simplify it, we get -4 over root 17. And then if we want to find the actual value of theta, we just take the arc cosine of both sides, because when we do, it'll cancel out the cosine. So we'll take arc cosine of cosine of theta is equal to arc cosine of -4 over root 17. Doing that cancels the arc cosine with the cosine, so we're just left with theta is equal to this value here, arc cosine of -4 over root 17. And if we plug this into a calculator, arc cosine of -4 over root 17, and we find that angle in degrees, we can say that theta is approximately 166 degrees, just a little bit less than 166 degrees. And this should make sense to us. We can get a quick check here, because if we just sketched these two vectors on a quick set of axes here, so let's say we have 1, 2, 3, 4, we have 1, 2, 3, 4, and 1, 2, 3, 4, something like this. So if we sketch the vector 0, 3, 1, 2, 3, we're going to get something like this. So 0, 3 would look like that. And then -1, -4, if we go out to -1 and down to -4, that looks approximately like that. So we have our two vectors there, and we can see that 166 degrees right there. So if both vectors were along the y-axis, if the yellow vector was right along the negative direction of the y-axis, that would of course be a 180-degree angle, and we're at a little bit less than that. So it makes sense that this angle could be about 166 degrees. And just to clarify, part of the reason that I wanted to sketch this graph is because, as you can see, we've got these two vectors, and you might be wondering, why are we finding the 166-degree angle instead of the angle that goes the other way, which would be this angle here? That would be the angle 360 degrees minus 166 degrees. And the reason is because this formula here for the angle between vectors, it'll always find the smaller angle. So 360 minus 166 is going to be 194. So that's the larger angle, that's greater than 166 degrees. So this formula is going to find the smaller angle, 166 degrees, that smaller angle between the two vectors.